In Part A, the MyElearn assistance system was developed to calculate weighted score, estimate GPA, generate academic summaries, and conduct a simple mental health survey using a basic C++ concept. However, the system could only store data temporarily and was limited in handling multiple records. Therefore, Part B enhanced the system by using array, file input-output, and pointers to enable permanent data storage and more efficient data processing.
Before accessing the main menu, the system requires a basic setup phase to identify who is using the program. This is handled by the initial loop in our main function. The program first asks for the student's full name, which is stored in 1D array. This name acts as a primary key for creating a personalized file name later on. Next, the user enters the number of courses they are taking this semester. We have implemented input validation here. The system will not accept a negative number of courses. If a user makes a mistake, the do-while loop catches it and asks again, preventing the program from crashing later. Finally, a for loop runs to collect all the course names and storing them in our global 2D array. This step is crucial because it registers the subjects into the system's memory, allowing all other features like the GPA estimator to know exactly which subjects we are working with. Let's dive into the first core feature, the weighted score calculator. This module is designed for precision. In a typical semester, a course is not just one grade. It is a collection of quizzes, assignments, and exams, each with different weights toward the 100% total. Technically, this feature uses a dynamic approach. We use a do-while loop combined with getLine to allow users to name their assessments like Final Exam or Lab 1. The program then enforces strict input validation. If you try to enter a score above 100 or a weightage that exceeds the total, the system identifies the overflow and forces a reset to ensure data integrity. The highlight here is the integration with file I/O. Instead of just showing the result of the screen, the program uses the offstream object to create a personalized report file, named dynamically using the student's name and course title. This means the student has a permanent printable record of their marks for every single subject.
This GPA estimator helps students calculate their final GPA automatically using their course grades and credit hours. It solves the problem of manual GPA calculation, which can be slow and tend to do error. The system can also take grades from the weighted score calculator, so students don't need to enter the same data again. In this part, I use array to store multiple subjects' grades, credit hours, and calculated GPA points. Each index represents one course, so the system can process many subjects in one execution instead of a single value. This loop processes each subject one by one. It checks whether a grade already exists, requests input if it's missing, then collects the credit hours and calculates GPA points for that subject. Here, I use a pointer that stores the address of the points array. By using pointer arithmetic, I directly store the calculated GPA points into the array using a memory addresses instead of normal indexing. After processing all subjects, the system calculates the final GPA by dividing the total GPA points by the total credit hours. This part generates a dynamic file name based on the student's name and opens a text file. The program then writes the GPA report, including course, grades, and final GPA, into the file to ensure permanent data storage. I use formatted output to display the report in a structure and readable table for my inside the text file. In conclusion, this feature combines array for structured data storage, pointers for memory-based calculation, and file output for permanent reporting, making the GPA estimation automated, accurate, and reusable across the system.
Finally, we have the data summary generator. This is the brain of the system that compiles everything we have processed so far. This feature demonstrates how we use global 2D arrays to maintain state. Even if you entered your grades 20 minutes ago in the weighted calculator, the data summary can still pull that information because it is stored in our course grade size and course name size arrays. The logic here is comprehensive. It doesn't just list grades, it checks your academic standing. Using a simple Boolean check, if your GPA falls below 2.00, the system flags it as a fail and give a warning message. If it's above 3.50, it offers a congratulations for making the Dean's List. By using IO manip functions like setw and left, the output file looks professional and organized, almost like an official university transcript. This creates a bridge between simple code and a real-world utility for students' life. In conclusion, this project successfully enhanced the e-learn assistance system by improving its ability to store, process, and manage academic data more efficiently. The use of arrays, file, input, output, and pointers allow the system to handle multiple subjects, save student records for future use, and perform GPA calculations more effectively. Therefore, these improvements make the system more suitable for real-world academic applications.